In this paper, we introduce DataDancing, a hybrid prototype exploring the use of whole-body interaction for designing visualization view management for 3D surfaces and spaces. Recent studies have explored how users of immersive visualization systems arrange visualization views in the space around them. Generally, these systems focused on visualization views centered at eye level in absolute room coordinates and interactions via handheld controllers. However, immersive technologies offer the opportunity to work with visualization views with natural embodied interactions using different body parts. For example, foot interaction in general HCI has been explored as an additional input channel for complex tasks or when both hands are occupied. The whole body can also be used as an additional modality to support implicit tasks using proxemic interaction. These novel interaction design possibilities represent a significant shift from everything we have learned about interaction with flat screens. In this paper, we introduce a design space for visualization view management, presenting a framework that identifies important aspects in whole-body interaction for designing view management systems. From this design space, we extrapolate several view management prototype surfaces, each demonstrating a different combination of interaction techniques and space use. We then conduct a user study that explores and evaluates the usability of 4 combinations of these surfaces. We recruited 12 participants and collected qualitative feedback and rankings for the 4 prototypes after completing a series of designed view management tasks. In the study, we used a novel body tracking system and foot pressure sensors to track participants' torso and feet positions. From our study, we observed novel behaviors and collected feedback from participants with a set of interface design implications unique to visualization view management. For example, participants suggested having world-fixed exocentric display surfaces for collaboration and body-fixed egocentric display surfaces for private use. Most participants preferred the curved surfaces as well as the novel foot interaction and proxemic interaction. Learning from the user study, we improved the interaction techniques and proposed 2 hybrid prototype interfaces that demonstrate the interaction possibilities of our design space. In the first prototype, Joe wants to find the day in December when his favorite street has the most pedestrian volume. Joe is standing in front of visualizations showing the pedestrian volume in December. The visualizations are in a small multiples layout on a wall display. This wall display can also be used in a collaborative environment. He uses bi-manual hand interaction to change the aspect ratio or pan the whole wall display, so that he can see everything at eye level. After scanning through the visualizations, he clicks on the bar which represents the data for his favorite street on the chart. Then, he drags visualizations from the world-fixed wall display to a body-fixed cockpit display. The cockpit display is a personal workspace that others cannot see. Then, he uses the foot interaction to pan the cockpit display and to change the geometry, especially when his hands are occupied with other charts. After comparing all selected charts in his private workspace, Joe finds the answer. The second prototype uses proxemic interaction to interact with views and switch between different surfaces. Here, we have Patrick, who would like to walk close to a wall display and see the visualization clearly. When Patrick moves closer to the wall display transforms into a curved tabletop display, which allows him to have the same distance to all visualization views. Patrick keeps moving, and the geometry transforms from a semicircle to a full circle. Then, the tabletop display becomes a body-fixed cockpit display, which follows Patrick. All the interaction in this prototype is implicit using proxemics. In summary, our DataDancing design space, user study, and prototype exploration contribute to future research and systems on visualization view management. Our work is the first to explore the effect of foot interactions on floor displays for visualization view management in 3D space.